Good evening, everybody. First things first, would you please turn off your CDMA handset? Or at least put it on stun. But actually just put it on stun because we want you to tweet and do other things during the event tonight to let everyone know what a great event we have. So just put it on silence mode. My name is Rory Moore, and I'm the leader of the organization CommNexus, EvoNexus. And this is my first time here since they've remodeled. How many of you were here last year when Marco Thompson did the robotics headliner? There you go. Didn't he do a great job, or what? And great having all those little flying things around. We don't have those tonight, but we'll talk something about that. Let me begin with a few things here. Want to thank our host, Qualcomm. Normally we have our programs at their large and auditorium, and did any of you here not get the memo and show up at the N auditorium? Marco Thompson, Marco, one of the founders of our organization, of course. So yeah, we're sorry about that. We had posted it 100 different times, and we knew that some of you would end up over there. So sorry about that. I want to thank our host, Qualcomm, for providing this terrific venue. They're just a wonderful company to work with, and nobody really has a better venue than Qualcomm in this town to host these kinds of programs. Also, we have many, many other companies, not only in San Diego, but outside of San Diego, that support our organization. And as you can see from the names up here, these are all large sponsors of CommNexus, EvoNexus. We've got a new sponsor, came on recently, ARM out of the UK. 5 Bars, DivX is re-energized and building out their company once again in San Diego. They're a new sponsor. And we have some big, huge international companies, as you can see, LG and Sony. But we also have a company that may not be a household name here, but it's a very important company to Qualcomm, and that's SK Telecom. We have 2 of their executives here tonight as well. They're the largest operator in Korea. So without the support of these great companies, we couldn't do what we do. And most of what we do is free. So this is one of our great free programs called EvoNexus. And raise your hand if you've heard of EvoNexus. Check it out, Rafa. Everyone raise their hand. Okay, so these are the stats, and I was telling Joseph, one of our speakers tonight, he'd never heard of EvoNexus, but he's from the Silicon Valley, so he thought that all intelligent life ended south of Gilroy, and that's not true. So there's intelligent life, Joseph, and there it is. Okay, and Admiral Davis, raise your hand, Admiral, where are you? The Admiral and I started the incubator about 2009 in October, got it rolling, and that's the results since inception. Approaching $600 million in capital raised and outcome. 48 companies currently in incubation. 48 companies. We incubate more companies than any VC ever had in his portfolio in San Diego, I'll tell you that right now. And we have 3 locations now. We have a location downtown, all software companies at 101 Broadway. We have a location at UTC, across from the mall. And then a 3rd location, we're doing the walkthrough next week in Irvine. So a 3rd location in Irvine, right next to UCI. We've admitted currently 48 companies spread out between 3 locations. We've had 8 acquisitions, created over 1,000 direct jobs, and we have great strategic funding partners. And my goal, in front of everybody here, by the end of year 2017, in 3 years, we'll break $1 billion in that number. We'll have over 2,000 jobs created, and we'll have 30 liquidity events by then. We have 8 already. Okay, funding partners. How is this different than the slide you just saw? All right. The answer is these companies invest in the incubator companies. So as we get companies that they enter the incubator and they hit areas of interest for Cisco or a Qualcomm, they provide seed capital, which is hard to get. Now when Qualcomm provides their early seed capital, guess what? The angels all start to pile in because they've gone through not only our due diligence to enter the incubator, which is really rigorous, they've also gone through additional due diligence with Cisco and Qualcomm. And now, if you're going to bet on a startup, that's the one you bet on. So Cisco, Qualcomm, both funding partners at CommNexus, and we expect more to announce in the next year. Okay, tonight's event, we've got executives from Cisco, Qualcomm, and what's that? Dr. Wren. MQ. Sounds like a three-letter agency. Okay, MQ. Dr. Jane Wren. Pankaj and Joseph will be speaking tonight. Their bios are in your handouts here. I've created some questions for them after they give their presentation. And then we'll look to you to provide then some other questions. I'll have some of my staff walking up and down, hopefully not tripping, up and down the steps with a microphone. So again, think of your questions. Make them short so we have as many of you as possible that'll get a chance to ask them. Okay. Connect with us if your phones are still on. There's how to do it. Give you a second to take a look at that. There you go. All right. I'd like to roll a very interesting video. I don't think this has been shown on network TV. At least I haven't seen it, but it probably should have been shown. My assistant and I found this the other day, and we were so impressed with it, we thought we would roll it tonight for you. It's a Cisco production. Roll it.
This is the cat that drank the milk and let in the dog that jumped on the woman who brewed the coffee.
Brew coffee.
That woke the man who was late for work.
All right. I gotta go.
And drove the car
Driverless mode engaged.
that found the parking spot
Find parking space.
Parking space found.
that alerted the door that opened the control room,
Hey, Bob.
that secured the data, that directed the turbines, that powered the sprinklers, that watered the grass, that fed the cow, that made the milk, that went to the store, that reminded the man to buy the milk. It was poured by the girl who loved the cat that drank the milk. The Internet of Everything is changing everything. Cisco, tomorrow starts here.
Isn't that terrific? Was that ever on TV? It was? Oh. I don't watch much TV, I guess, or at least I TiVoed it out or something. Okay. There you go. All right. Our first speaker, Pankaj Srivastava, is here. Came all the way down from San Jose to visit with us tonight. And I'm going to let him make his presentation. And then after Pankaj, we'll have Joseph and Busaba from Qualcomm. Pankaj?
Thank you, Rory. Thank you. Thanks, everyone. What a great crowd. I lead a software platform group, an applications platform group in Cisco.
Okay.
I met some of you earlier, and you asked, why software in the network? Well, let me ask before that, how many of you have been tracking or heard about or understand IoE? Now, my kids asked me, what was I doing in San Diego today? So I'm going down to present on Internet of Everything. And they said, you keep talking about that. What is that? I said, well, how many, let me see, show, how many of you email? I asked my kids and their friends, how many of you email? Show of hands. How many of you blog? How many of you use Instagram? Those of you who have kids are probably using Snapchat to see what they're posting. I said to my kids, just imagine a world where every toy, everything you own, every device, you could make a blogger, an emailer, a tweeter for what you care about and what it's doing. That's kind of what the ad was saying. And that's really what the Internet of Everything is about, is that most of our assets in humanity are not on an open network. They're not on the Internet. When you connect them to the Internet, as the world is progressing to do, the possibilities open up. How many of us didn't have a smartphone 6 years ago? Now we're all connected to the Internet for not just experiences, email, but all kinds of applications. Imagine every device becoming essentially just like your smartphone. That's really where it's headed. I'm going to take you through a journey on why we think the Internet of Everything is important. Of course, we're going to instrument the connectivity there, but if you just connect everything, you haven't really allowed it to be a true blogger or an emailer or a tweeter in the architectures that we participate in. So I'll show you that really the Internet of Everything is about connecting the globe to the Internet, but once you do that, giving it a nervous system where everything, no matter how inanimate, how dumb, how uncontrolled it is, becomes part of the intelligence of the humanity. Now, I'll just give you an example real time of what my team and some of our colleagues here have been doing for the railroad systems in Europe and other places. The railway systems have a lot of extra inventory because one of their biggest fears is derailment. A lot of the derailment is caused by wear and tear on the ball bearings, wear and tear on the couplings and other things that they just have no visibility to. So what they do is they just have regular scheduled maintenance, but even that is often not enough. So the equipment is underutilized. There's a lot of value tied in there. There's issues of derailment. Then you get into the passenger train. It's not just that. People are taking their kids in Europe where there's a lot of train activity, and they're saying, this is a digital cave. This is not where I get all my experiences. How do I get the experiences I can get at home to participate in the train journey? So one of the things that we've been doing in the railroad systems around the risk environments is we've been creating hardened, I call them extreme condition routers and switches. These routers and switches, first and foremost, will give the connectivity to the world of what's happening, but they also have capacity, compute capacity, application capacity, where we're filtering data that's streaming from all kinds of sensors. Some are Bluetooth enabled, some are Wi-Fi enabled, some are 4G. Whatever the modality, it's all getting onboarded onto the Internet right there in the train. And once we do that, not only are we just sending all that back, we're actually filtering it and making data, recognizing the events. The decisions of how that's done is being done by the railroad operators. So it's really about turning everything on that train that needs to be a little tweeter of what it's doing. Now, our partners and some of our application teams are building all kinds of interesting real-time dashboards. This is one that's in trial now with some of the rail operators, as well as their command center players. All of this is HTML5. HTML5 is the next big platform for the mobile environment. The railroad operator gets this on a hardened tablet, and they can see what's happening in terms of the sensors. They're getting the sensors. The data is not just flowing at the bottom. It's data in motion filtered for what are important events that they should care about. They're getting the video views from the IP cameras that are now being put in for very low bandwidth streaming of video on what's happening at key points in the railroad. They're connecting into the social sites that matter to their enterprise, and they're bringing in some of our collaboration technology if they have to deal with an incident such as WebEx. And this is all going to be controlled and monitored on the tablet that sits on the railroad operator, the supervisor, and then there's all other kinds of applications like this in the passenger world as well. So suddenly the whole train and probably 25,000 sensors on it are now little websites Instagramming their issues up to the railroad operator. That's the world. Now if you've been tracking IOE, it seems incredulous. It seemed incredulous to me 2 years ago as I started moving our software platforms to this world, that there's trillions of dollars of opportunity locked in here. But there are. And we've come to that realization because with all of us connected to the internet, all our phones connected, it's still only 1% of humanity's assets and capabilities that are really connected to the internet. Most of the things that we want to involve are not sitting on our network where we can get to them. So if you bring 99% of that world here, the conservative predictions are that by 2020, the inflection's already happened, 50 billion smart objects will be connected. We're at 25 billion almost with smartphones, our laptops, our servers, and other things. But imagine all those devices connecting. And I believe this is conservative because we do a lot of business in China. Internet of Things is one of the top priorities of the Chinese government. They are creating cities, 20 new cities of 10 million people each, and they're going to make them completely massively connected. And all of those things will be as engaging, as involved as your kids, as your phones, and when we tweet and blog, but they'll be connecting to business processes. Business processes that matter to the infrastructure owners, the manufacturers, all the people who've been doing this in more costly ways outside of the internet. And what are some of the trends that are driving this? The world of IT that we've all grown up with has converged onto a common network over the last 20 years. Whether you work with your ERP system, your payroll system, your video systems, your PCs, your servers, your data centers, we can get to most of that today on one environment, one network. The mobile environments can connect to it. The operational technologies have all built proprietary networks, very expensive, but very proven over the last 50 years, but legacy systems for traffic control, manufacturing, safety, what have you. Trains, machine parts, access points, video cameras, all these are future servers and data centers that need to move to the world of IP. And when they do, what we've suddenly done is allowed everything out there to participate in what we've taken for granted over the last few years. I can approve an invoice while sitting here. I can connect with the family over FaceTime. This is what, for instance, the oil and gas industry wants to do. They don't want to just do a FaceTime with other workers. They want to do a FaceTime with a critical valve on an oil rig when it says it's having an issue and get a video feedback. So that's really what's about to happen next. We see this as a major transition, and I think the market's also validating it, in the internet waves. The first wave was connectivity. We all experienced that in the early 90s. Access to information as soon as you got on the web. Email, search, and what have you. Business process over the internet, e-commerce, the turn of the century. We could now actually do automatic bill pay and stuff like that. Immersive experiences, YouTube, FaceTime, video chat, Jabber, what have you, cloud-based video, social interactions. We all use those today. We take it for granted. What we're talking about, the Internet of Everything, is like that railroad example. Suddenly, things that are now part of our world of the Internet will connect to our processes, provide us data, connect us to the people that help us solve the issues that we're reporting to. Whether it's in the home, where the cat had to let the dog in and get some more milk, or it's actually on an oil rig where certain things are collapsing, where multiple partners have to look at it instantaneously. Those are the kinds of solutions we and our partners are building on this connected, intelligent infrastructure. So if you take IoT, the Internet of Things, all these things now connecting onto the world of IP, becoming intelligent, becoming participants in our chatter, in the business process social environment. You connect them with people, you connect them with the processes, where today most of our processes are around our data sources and our databases, and you connect the data in, what you're doing is really creating the Internet of Everything effect. It's a nonlinear effect when you bring all those 99% of humanity's assets into what we're already used to doing with each other, with our servers, with our data systems, and our application systems. And that's really where the impact comes from. Now, there's a lot of value at stake here, and we keep scratching our heads and saying, is this really true? But we're seeing these are just the first set of use cases or solutions that are emerging where there is so much low-hanging fruit. legacy networks, proprietary environments, a lot of legacy assets that have been managed in overlay networks or separate environments for asset management, asset monitoring. I think we talked today with the healthcare teams here about asset monitoring for medical devices, patient monitoring with those devices. Employee productivity, supply chain, real-time supply chain. Right there is probably $2 trillion of inventory costs and inefficiencies tied in there. Logistics, real-time logistics. Customer experience, where the customer experience is not just the retail experience that we're trying to get anywhere, anytime, but it's also the customer experience for the train passenger, for the person that's actually contracted to operate the machinery in the shop floor. And also shortening the time to innovation, R&D. Now, we're seeing a lot of industries take this on. We're being the software team in Cisco, bringing the application. We're also collecting all those application cases. We're bringing in partners rapidly. We're also pushing very hard to get the silicon and the semiconductors ready for this wave. But these guys have already left the station. They're already moving fast into this because this is where the next wave of their growth and profitability come from. And we're also seeing a lot of players in healthcare and other industries emerge. We're already engaged in the industries of process manufacturing, discrete manufacturing, energy, transportation, cities, retail. All of these places have traditionally used IT and mobile infrastructure, application infrastructure, primarily for what we call the carpeted floor, for serving the decision makers. But their real business happens in the field. In the oil and gas, they call it the extreme condition environments, in the field where the energy sector. So a common principle across these early adopters is very distributed operations that have never been served by IT or the internet. I'll just give you an example. Today, some of our large oil and gas customers have been telling us that whenever there's an issue that requires an expert on an oil rig, it costs $100,000 in round-trip helicopter fares to get them in and out, just for that. Now, 99% of the issues they're going to look at, they could actually look at with a video stream. What if a sensor triggered an event which turned out a stream that was managed over a satellite connection for low bandwidth that invoked a collaboration between 3 experts for the next 5 minutes? All that is possible when you instrument that oil rig to be part of the Internet of Everything. In the smart cities we talked about with China, these 19 new cities with 20 million more people, 200 million more people at 10 million each, are going to have everything connected to the Internet. Why? Because they want to compete with the tier 1 Chinese cities that have taken most of the initial wealth. They want to provide an even better environment for us to engage and collaborate with on their shop floors, in their buildings, and all those services. The retailers are also pursuing this. So all the use cases are just coming at us at a more accelerated pace, and we've got to instrument this. Operational efficiency, we talked about, are some of the drivers. There's a ton of new revenue streams. Part of those smart cities in China, they're going to actually turn every little wall into a HTML5 enabled advertising point. That's where they're headed. Regulatory compliance is also driving some of this, where the systems and the networks that existed that are proprietary cannot scale to the demands that are coming. Now, what are we doing, and what's the world looking at us to do? Connectivity is the baseline. We're extending our connectivity to work with the protocols that sensors are used to, that machine RFID tags and things deal with, and also providing hardened routing and switching into that environment. We're also providing the network infrastructure that allows that convergence for a managed network. But that's just the baseline. That gives you, I would say, the skeletal system for this and the musculature. Really, the nervous system comes into being when we can provide distributed application capability, distributed decision support, not just business intelligence. I met some of the Teradata folks when we were talking about this earlier, but actually local operational intelligence about what's happening near real time. Security anywhere, anytime, and then connecting it back to the cloud. Not just the clouds we're used to, the iTunes and the Amazon clouds, which are the business-to-consumer clouds, but very secure business-to-business clouds where trading partners can all now support the service. So this is really an end-to-end environment where this connected environment is going to connect not only the things, but provide the intelligence and the head end all securely integrated for those kinds of services. Once you do that, everything can now participate in the right kinds of processes. So we know, and we're seeing this, billions of new devices coming on board. We've got to instrument the Internet of Everything connectivity and the app platforms. That's one capability. We've got and the app platforms, by the way, are not just the fixed app platform, but also the mobile app platforms. As you saw in the railroad example, that application should be consumable in a hardened tough tablet or on a touchscreen or what have you. The business-to-business clouds, the next generation clouds, which are going to be very secure, available with good bandwidth anywhere, anytime globally, allowing multiple players in that industry to connect. And then analytics. The big data systems, the data warehouses will provide the brain functions and the insight functions, but we've got to provide the eyes and ears in the network where we're collecting, filtering, handling the data, and that connected analytic fabric on top of this is also driving a lot of our requirements. So that's where we're focusing. We're saying if we can connect everything, we can provide the environments for that intelligence, we can bring our partners to create that capacity for that intelligence at the edge and connect it into these cloud environments, and we're already starting to do this in many industries, you can change the game. You can change the game in terms of how all those things that were never on the internet can not only be frivolous tweeters, but be participants in a business process. I'll take you through a little more detail in a couple of areas of this, and then we will soon be talking more in the market about our analytics capabilities as well. But what are we doing at the edge of the network, where the rubber meets the road, where the devices, where the machines, where the chairs and things connect to IP? What do we have to do there? What are we doing in the cloud to provide the head end? I look at this as a nervous system where the internet, the connectivity, the edge intelligence provides the nerve endings, not just, and then the cloud provides the brain function points. At the edge of the network, we can't take the traditional computing models anymore. And if you came from software like me, client server, web, mainframe, these were all client server architectures where most of the data was processed back in the core. We'll still have to do that, but that won't support the needs of the world that we're about to see, which is very distributed. What we're learning from, for instance, just one oil rig, you're going to get 10 terabytes of data a day from those sensors. Most of it, 99% of it, is useless, and most of it you could never provision the bandwidth to make it cost effective to bring it back. But there is a lot of issues involved in there that if you can provision an ability to deal with compute at the edge, application, data filtering, analytics, automation, integration, all that we're building as capability that our partners can plug into these routers. Into those hardened form factors, those solid state form factors, if you can provide that fog layer can provide a constant environment for machines and equipment that don't use the internet like us. Sometimes they're on, sometimes they're asleep, sometimes they'll send data, sometimes they'll actually recognize an event. Other times they'll be in motion, they won't come into a connectivity zone for a while. But you've got to provide a reliable place to handle what's happening over there. So we look at the distributed world involving both the device, the connectivity, enough capacity for all kinds of intelligence to be embedded at the edge, connected to the core systems that drive our businesses, the ERP systems, the big data systems, the data warehouses. And so fog is going to be key. It's going to be a three-tiered kind of model. What are some of the early solution patterns we're already solving, and many of our ecosystem partners the system integrators are already asking us to build. We look at it in three classes: machine to machine, machine to people, and people to people. And all of these involve the intelligence that machines couldn't connect to our internet before. In the machine-to-machine world, the early patterns, and this is just the early patterns, are around remote asset monitoring, around predictive maintenance, where you're not just looking at what's happening there, you're putting enough intelligence to filter and give you some insights on what's happening. You're putting your agents onto that architecture. Flexible production support in systems that are moving assembly lines, that are moving oil and gas. How do you actually recognize and optimize what's happening there, either by bringing the insight back through the network or actually empowering that system to do it? In the machine to people, it's really bringing the intelligence that we're used to from all our analytics systems in our businesses right to the edge of operation. It's what the industry calls operations intelligence versus business intelligence. It's where the activity is happening, recognizing and filtering the events, looking at 3 more devices, and serving up a critical event or a near critical event. The software technologies are there, the networks coming together, you bring it all together, and now ships, oil rigs, oil pipelines, ambulances, they can all be providing real-time insights to the operators. The operators have never had that kind of intelligence available to them. People to people. It's what we talked about in the oil rig example. The experts are few, the field workers are many. The experts are often flown around to the point of issue, and it's not enough to have them sitting in a contact center. You've got to connect them in. You've got to provide them the decision support. You've got to provide them the multimodal insight, the stimulus of what's happening there, whether it's the sensor data that's getting filtered in, the video feed as you need. All those kinds of requirements are coming at us, and we're starting to instrument those. And the ROIs in this are intuitive, but when you look at the cost savings from the traditional models, that's where some of the trillions are coming from. We're also starting to glean a lot of what we call network and system architecture patterns. One is from cloud to fog. Yes, you will need the centralized data to make the longer historical insights, but you will need more data visualization. Yes, you'll need data as a service where the train operator we saw can publish the information coming from the train. But you'll also need that analytics at the edge. Right there, providing filtering systems that can sit on the firmware and handle the data that's streamed, pick out what's important, correlate it, and get that back. Because the way these systems and these machines move, you couldn't put enough people to provide decisions every step of the way when you have the visibility of what the issues are. And we're also bringing in all kinds of integration technologies, because what people are looking for is once you can sense reliably, you can understand reliably what's happening on that railroad in that oil rig, and you know the issues, the question they're asking us is, why can't I respond through this architecture too? Why can't I put little workflows there and so the memory requirements on the edge of the network in the closets the network connects to these environments is growing too. There's a lot of software technology requirements emerging that we're building out that'll complement the traditional software environments, putting that right into the network from our servers to our routers, switches to our cloud. But it's not just about that cloud to fog decision support. It's also about automation. If you're getting the data intelligence, if you're able to provide filtering, not just blind filtering, but intelligence into that, levels of cognitive intelligence that we can embed in the network, you can actually, most of these players in these industries are putting enough silicon on their machines to let them do the self-optimization of the issues that are arising. And what they're asking us to do now is also provide automation at the edge that you can have self adjustment as well. So all the way to automation, where eventually, a few years from now, as we get the first 50 billion new devices ingested, we'll actually be supporting a lot of automated self-serving systems as well. So 50 billion devices are connecting in. Connecting people, process, data, and things is transforming these industries. We've talked about some of the examples. The edge of the network and the cloud are demanding more capability in the hardware where we can put that app environment. Our partners, our system integration partners that drive the value for customers can use that whole fabric to create a sense and respond nervous system on top of this that can react to the demands of those systems. Now we'll look at the cloud world. This is the head-end part of it. What we've already done in Jordan is put a radiology cloud that connects not only the doctors and the hospitals to this environment, but also to all the other countries that come and their patients that come from medical tourism. Utility grids are looking for the cloud to provide that point of command, control, visibility, not just for the players, but also for all the partners that are supporting these systems. Oil rigs we talked about. So the trend that's happening at the macro level that's driving a lot of value is most of these industries are saying if I can get this kind of capability, connectivity, and intelligence and capacity in the hardware that makes up the network, then I'd like to use the mobile, the fixed assets to create business processes for the industry. And many of them are actually taking bolder steps saying, let's take multiple services, some we don't own, and create industry as a service. This is going to be where the world of IoE comes together with the world of industry and unlocks a lot of the value. In order to do that, there's also another infrastructure play that's coming out, which is that just like the internet before the web was often an isolated set of internets and the world of TCP/IP brought it together, there's a growing demand for lots of cloud nodes because it'll take many brain centers to solve these problems. And what people are looking for is, they call them hybrid clouds. They're not they're not B2C, they're not public clouds, they're not private cloud, but they are clouds shared by trade partners in a very secure way. We're working on connecting all of that on a common fabric where all those devices, wherever they are in the world, can connect to the primary owner's cloud, connect to the supporting service provider's cloud, and all the services connect in and solve the problem it often takes 5 or 6 players to solve on these kinds of equipment. So the head end is going to provide the brain function, but it will require also a next generation cloud infrastructure that ties all these devices into very scalable, very performant, and very secure environments where all the players in that industry that are participating in that industry as service can come together. I'll just take you through some of the things we're doing with this cloud environment into places like China where the buildings are being instrumented to be sensor heavy and all those capabilities, and the roads are. Smart parking, intelligent lighting systems, safety and traffic flow systems, connected buses, waste optimization. There is a ton of revenue value tied in this for cities. The smart cities see this as a way to finally beat their budget challenges. Instrumenting all of this is just the civic services before we get to citizen services. New revenue sources. Citizen experience is another play by which these new cities will compete with each other, compete for our attention as well, and look for those experiences as a way to drive more transactions to their world. We're already putting a lot of connected factory architectures together. The initial use cases around plant-wide wireless, flexible manufacturing, secure plant, but they're already starting to take the bold steps with that intelligence in the network and the cloud supporting that decision around near zero time types of activities. Fault isolation, new product integration, and flexible assembly. These are huge value points for just this industry alone. These are just some of the early use cases. So as we talked about the nervous system, just on the head end side of things, we believe the network will provide connectivity. It will be a place for all the hardware and infrastructure to provide the intelligence. The mobile environments will provide the operational control for the workers. But the cloud, the secure clouds, will provide the head end, the brain functions, the multi-party brain functions that support these operations. When you bring that cloud environment with the network, you've created not only a nervous system, you've also created a brain capability to support the processes that are coming out in machine to machine, machine to application, and machine to people. Next generation supply chain, remote operations, field device management, citizen services are just some of the early applications that we're starting to see that are going to drive the value. And that's just the first wave. So in conclusion, I told my kids IOE is about everything being a tweeting point, an email point, but it's not about frivolous emailing or tweeting. It's those things using that capability to communicate to their stakeholders and their operational owners about their issues, their challenges, and the support they need, which most of the time goes unaddressed. And that's where some of the value is locked up. Thank you.
Thank you. Thanks, Pankaj. Our next speaker, Joseph Busaba with Qualcomm. Joseph came to Qualcomm via Atheros. I think Atheros is still the largest acquisition Qualcomm's made to date.
Right.
Okay. Well, we hope there's some acquisitions that are even larger out of EvoNexus for Qualcomm one day.
Sure.
Joseph.
Thank you. Good evening. First, I want to apologize up front if I had to stop and drink some water. I have a pretty bad cold. It happened a couple of days ago as I started preparing for this, and as I was told that I have to present. So again, I apologize if I have to stop. I'm going to start. I think I have about 20 minutes. So what I want to talk to you about is the Qualcomm view of the Internet of Things. Or Internet of Everything. I think this is something we share with Cisco, where we call it a little bit differently than what other people do. So I'm going to share with you the vision that we have, what we're doing, how we see the market, and how do we play in that, and how we are planning to drive the market moving forward. So let me see how this thing works. Which button? Okay, here we go. So talking about the Internet, the Internet has gone through multiple waves of evolution in the past 15 years. It's amazing. I think some of us have gone through it where the first time we had or we did access the Internet, it was about doing it from a PC, sitting in some lab, and getting really some basic access to information and to browsing. So that really the first wave was about our ability and allowing us to get some information. The second wave was more about how we can consume data, how we can share, how we can use that to entertain us and people around us. And it was involving more and more devices, mobile phones, computing, tablets, and other things. The third wave, which I believe is upon us, and we're starting to see it, is really about Internet of Everything. It's about every device around us getting connected. We're seeing that today already. The market is still very fragmented, but the momentum is starting to build. You look at what people are looking at doing, whether it's inside the home or out on the go, in smart cities, in the car, etc. The different applications, the different use cases that people are targeting, are amazing and will impact our life in every possible way. So the Internet of Everything is starting to happen. It has ways to go, but it represents a significant opportunity, I think, for all of us. So, really looking at the way it's evolving, the way it's growing. While it's still fragmented, it's small today. It's expected to, reach probably over or more than 20 billion connected devices by 2020. You look at different reports. Every report you read talks about billions and billions of devices. The thing is, it's happening. We see it happening. The question is how and how fast, right? And the way at least we see it evolving is, the consumption or the number, or as the number of devices and the number of use cases really increase, the amount of data, the amount of, or the size of the data pipe is going to continue to increase. So really having the right technologies in place to make that happen is going to be critical. So the way, as we look at it, from our technology perspective, looking at the smartphone and the cellular technology where it's going, going from, the CDMA or 1X to 3G to 4G, etc., providing a bigger pipe would allow, the fatter pipe, or would allow the capacity, the data capacity to enable all these type of devices. So really at the end of the day, or the bottom line is, the opportunity is tremendous. Having the technology, having the capability is going to be extremely critical for companies to really leverage, this growth and be able to benefit from it and drive the ecosystem as well. As we look at the market, you read different reports today, you get different segmentations. Everybody or every market analyst, shows it a little bit differently. They cluster things differently and all that. We struggled quite a bit, frankly, as we started looking at the market to contain it in a way that we can isolate it or be able to nail it down to products and channels. And we were able to bring it down to 3 major clusters. It's the first one is about the body, about personal. These are devices that we wear and we only use. Looking at the different types of devices that people are doing in wearables today, for example, you have different types of watches or different tiers of smartwatches, smart glasses, body sensors, trackers. This is a category really that's around mobile devices, around, at least from a Qualcomm perspective, around our DNA with respect to how we can leverage the technology that we have in place to build compelling solutions for those, applications. Another key cluster is around the smart home, the connected home, and about enabling really the ability to have complete ecosystem of devices inside the home that can deliver capabilities from entertainment and media streaming, media sharing, etc., gaming, etc., to all kinds of control devices from, health to home automation. Talk about, smart appliances, talk about, thermostats, talk about LED lighting. Very much everything inside the home is becoming connected and is becoming smart. So this part of the market, at least from where we are and where we come from, it's very much an extension to our mobile world, the smartphone, the tablet, and what goes around it from all these devices. And especially as we look at how that ecosystem is developing, at the end of the day, the smartphone or the tablet is still in the center of all that. All these devices are forming, they're happening. The controller or the control or the device or the hub is very much the smartphone at the end of the day. And one thing about the smart home, which is I think probably a lot of us see today, is we buy smart devices, whether it's a TV or a game controller or some other device that is connected as well. You try to make these things work together, and good luck. And even us that I consider myself a smart, an eligible, let's say, consumer here, I give up on that and I don't do it anymore. So what at the end of the day, what's going to drive adoption is the ability to create this level of interoperability between these devices that can make the user experience really compelling for my grandmother or my mother here, right? So what we bring to the table in addition to, or what we're working on in addition to having the devices and the technology from a hardware perspective, is the middle layer to enable complete interoperability between devices, regardless of the brand, regardless of what the device is, that can make or create this seamless interaction between all these devices. This is a technology that we created called All Join, and we drove it through a standard or an open source alliance actually. So bottom line is the smart home is happening, but you need that level of interoperability to make it, really seamless and to get the propagation going. Now the third part of the ecosystem that we kind of defined was around machine to machine or smart cities. And there it's really about industrial applications, commercial applications, transportation, energy management, and things like that. Things around the house that allows to create that level of efficiency and security around us regardless of where we go. Talking a little bit about smart cities and what we really see there. So the speed of how the expansion is happening within cities is actually unprecedented. Where today I believe is about 50% of the world population is in large cities. By 2050, the studies show around 70%. So that by itself, as you start looking at that level of congestion and how it would happen, creating the smartness in these cities become very, very important, right? So in that sense, having the ability to manage resources effectively, to provide public safety, to reduce emission, to create that level of efficiency that can enable this the ability to get this level of congestion in these cities is going to be important and critical. So at the end of the day, as you look at how these things, are coming together, the underlying technologies that are going in there are going to be very critical and very important. And again, from our perspective, the way we're looking at this, coming from a smartphone or from the cellular side, and how we expand to enable these pieces is what we're really focused on. And for this let's say propagation and adoption to happen, these type of solutions will need to this technology will need to exist and evolve with time. So we're really focused on how we can enable these types of capabilities that can create these use cases and user experiences. Talking about some of the use cases, that we see, in smart cities. My colleague, talked about some of those already. So, today we're already actually enabling some of these with our wireless technologies, or specifically cellular technologies, and Wi-Fi. Talk about smart parking. Today, you have to pay, at the parking lot, to park. Here you're talking about, enabling smart parking where, your car will be detected, via the cellular network where you are. It'll show you where the parking lot is, and it will get, it will get charged automatically via your credit card. Talking about smart lighting and how, commercial lighting will be used in these types of environment. Wireless charging, what's wireless charging, and how, what technology is going to be required to enable, wireless charging for electric vehicle. And talking about, building automations, smart buildings or smart building management. Talk about road sensors. So a lot of different types of applications are going to be enabled to create that level of user experience, and use cases. Talking about the car, about transportation. The car is another example here where, the smart, let's say, environment is going beyond, let's say, the home or beyond the building or other things. The car is very much becoming an extension to the smart home, actually where, the expectation from the consumer is that I get in my car, I want to continue doing whatever I was doing at home. If I was watching Netflix, I want to continue my movie in the car. If I was sharing content with my sister or my brother, I want to be able to continue to do that. It's funny. I bought an Audi, a few months back, and I dragged my daughter with me to the car dealer, and she hated it. She didn't want to do that. I got the car. I get in the car. I turned it on, and I told her, you know what? Give me your phone. I want to connect you to the Wi-Fi network. She's like, what? Does it has Wi-Fi? The car has Wi-Fi? And from that time, every time I tell her, come, let's go somewhere, she really loves it because now she has her iPad, connected via the car Wi-Fi. And that Monday she went to school, and they go to school and they share what they did over the weekend. So she said, everybody was sharing, and it was boring. And I stood up there and I said, hey, I went to this weekend to the dealership with my daddy, and we bought an Audi. And she said everybody was talking, they didn't pay attention. And then she said, but I was surprised to see that it has Wi-Fi in it. So I was able to connect and continue doing what I was doing. And she said everybody looked at her and was like saying, wow, this is amazing. There's a car with Wi-Fi, right? So the point is, but the message here that I'm trying to tell is, the car, you look at what the car OEM's doing, they're bringing the same the smart home experience into the car. Talking about other aspects even of the car and of safety, there's the car-to-car communication or car-to-infrastructure communication that car companies are working on now. The U.S. Government approved the DSRC technology. I don't know if you guys have heard about this, but this was about a year ago, which is really about mandating every car in 2018 and beyond to have Wi-Fi capability that can talk to other cars on the road for safety applications. So this is really for collision avoidance and safety in cars. You're driving, you're behind a truck, you want to pass, another car is coming by, Wi-Fi communicates, you have Wi-Fi in the car, it's sending beacons, it detects another car coming, it gives you a warning, so you don't pass or you don't risk it, right? So really the wireless is being looked at for different types of use cases inside the car beyond just entertainment. So a lot of that is happening. We bring a lot of technology into the car as well, whether it's Snapdragon technology or connectivity. And we've been really very active working with OEMs on how we can enable some of these use cases inside the car. So it's another really compelling opportunity actually that is really coming on very strong. We expect by 2018 more than 60% of cars to be connected. So it's really picking up a lot of momentum. Talking about the smart home. So this is another area where coming at least from the Atheros side or even within Qualcomm, right? We're very much a consumer company as we talk about the wireless and how we're deploying wireless, whether it's for for smartphones or for different types of connected devices inside the home. So the home or the smart home is going beyond just the traditional consumer electronics media type of applications. As I mentioned earlier, it's going into home automation, home management, appliances, all kinds of different appliances. Actually, this is funny. I was with my boss. He's Indian and he's vegetarian. We were in China visiting with one of the top OEMs there. They make about 250 appliances per year, or they ship. And they do everything, every appliance that you can think about, including rice cookers, including just anything you want. And we were talking to them, and I know that they've been designing our Wi-Fi into a rice cooker. And we were meeting with them. It's like, why do you want Wi-Fi in a rice cooker? Why do you want to connect to the web? And they said multiple reasons. One, you want to be able to download recipes, which is okay. You get some recipes. You load it with your phone, and maybe you're in the store. You don't want to wait. Okay, you can do that remotely. Great. But the thing that got my attention was that the other thing that they want to do, they want to be able to collect information on how consumers use the rice cooker. What type of rice do they use? How do they cook the rice? I didn't know that actually you can cook rice in different ways, right? So how you cook the rice, what you do, etc., etc. And that information they want to collect, they want to aggregate the data, and they want to take that and potentially sell it back to the rice people or to the manufacturers. So it becomes about how you can aggregate the data and monetize it in one way or another. And my boss, being vegetarian, he loved that, and he really wanted to buy one, and actually he came back and he found one on the internet. Okay, so again, the smart home is happening. A lot of application, a lot of use cases. People are being very creative. It's really exploding. The underlying technology under that, it's inside the home. Of course, it's around Wi-Fi. It's around Ethernet, power line communication, Bluetooth for proximal, and Zigbee and other things that are coming up, for home automation as well. And then on top of the hardware, there are these software capabilities, that bring differentiation actually, and bring more compelling use cases like all join that I mentioned earlier, that gives the interoperability across all devices, or services like Stream Boost, which is more analytics and data aggregation. So these things sit on top of that to create the additional capabilities to make the compelling use cases. Some of the use cases here, I'm running out of time, I guess. Some of the use cases inside the home that people are looking at enabling, and I'll give a couple of examples here. You're talking about what type of, let's say you're in the home, you have your appliances on, the washer cycle is done, it sends you notification to your TV that you're watching that the dryer is done, or the washer is done, or the coffee is about to start, or the milk in your refrigerator is getting low, or right. So I mean, these are actually real use cases that people are working on enabling and really driving with their ecosystem. The other key cluster that is actually gaining a lot of excitement and momentum is wearables, right? And specifically watches. We believe by 2018 about 200 million wearables will be sold, and 1/3 of that is expected to be watches, right? And we're actually seeing a lot of let's say interest in watches from smartphone companies. They see the watch as a peripheral. And even now, the watch companies, the traditional watch companies like Cisco, and others, that want to now create these smart watches as well. So looking at that versus things like the Fitbit or the Jawbone, where you have these small trackers that can enable some type of single function use cases. So there's a lot around wearables, and there are speculations about whether some of these things will merge into single devices where a watch can do everything else, or whether you continue to have separate trackers for single or dual function capabilities. So there's a lot of that happening today. The bottom line is there is a lot of momentum there, and how fast things will happen, I guess will depend on people like Apple and Samsung and these guys as they bring these devices, as they provide the compelling use cases for it. So, but from our side, we're seeing a lot of momentum there. Snapdragon technology or coming from the smartphone side and from the low power and all that is really providing us an edge in here to make this type of device a reality. Because at the end of the day, if you're going to have a watch that you have to charge every 5 hours, that's not going to fly, right? So having low power, having the always on, always connected capability is very critical in this part of the market. So the key point I want to highlight here without dwelling too much is, again, looking at how we are from the personal to the connected home, it's about really enabling a complete ecosystem. For this to happen, you need to have the ability of enabling a end-to-end ecosystem with fully interoperable devices. And this is where you put the different devices, the different pieces together from hardware, software, and middleware to make it all interact. It makes it a reality, and it makes it compelling, and it drives adoption. And with adoption, everybody wins, us and our competitors. One thing people tell us, why did you make AllJoyn open source? We made AllJoyn open source because we wanted adoption to happen, because we wanted people to be able to use these technologies and these capabilities, in a way that will provide them the user experience, right? So the ecosystem is happening, and we're actually driving quite a bit of that pieces of it. Really from the edge of the cloud with our access point and router technologies to any device in the home. The underlying technologies, quickly, I think I ran out of time already, but again, as you look at these devices, whether it's the personal and the wearable or the smart home or even in the smart cities, it's about the underlying technologies under that includes or cover multiple things from multimedia capability with our Snapdragon processors. Power management is extremely critical, as you know, with these wearable devices. Graphics, graphic capability, the DSP, and sensor hub capabilities. Software is, as a lot of you know, is very critical in here. Visual computing and voice processing, connectivity, the portfolio from Wi-Fi to Bluetooth to Zigbee to whatever, just name it. The ability to do peer-to-peer and point-to-point. Position and location is very critical, how that can be leveraged in different parts of the ecosystem. And on top of that, the last but not least is security. And I have one, I think I need to run a little bit faster in here. The point here that I wanted to highlight is, as we look at how we enable this ecosystem, it starts from our side, from the smartphone. In two ways. One, in the technology, having the appropriate technology that can be used in these different peripherals, around the house or in wearables and other parts of the ecosystem, or in how you control it. At the end of the day, the smartphone is the main hub that's communicating and controlling all of these devices. The advances that happened in the smartphone in the past 6-7 years actually has provided tremendous capabilities that made a lot of the IoE devices that we're working on today really feasible. Power is very critical. The processing power, the capabilities. Today you can do with a small phone what a PC did 10 years ago, right? And that's even going to the IoE devices with respect to the additional capabilities that can be done. So that smartphone technology is evolving, and it's helping us a lot in really creating and building this ecosystem. Let me skip here quickly. I want to talk for a minute about security. As you have more and more devices in the home, we're even more vulnerable to attacks, right? So having or the security piece even becomes more critical when you have 100 IP addresses or more in the home. So from our perspective, coming from the cellular side again, and having done that in our smartphone for generations and generations, we're leveraging that technology in our IoE devices to create completely secure devices that we deliver to our customers. So that's something that we do on top of let's say the devices and the solutions that we offer today. Talking about, let me skip, the only point I wanted to highlight in here is that we're so dependent today on our smartphone. It's amazing how dependent, whether us or our kids. So how the way the ecosystem is happening and how IoE is happening, the ability to control all your devices makes it even more compelling and increase the dependency. Last, it's really about how do you deliver the capability to customers, how you enable them from a technology perspective, from tools and from design, etc., to get them to help them with time to market, and then how do you enable the channels to provide the partners and the distributors, etc., to get access to the products and to the capability. I think the last slide I have is really around. It's I mean, we call it, or we used to call it a dream. The dream is happening. The Internet of everything is happening. The smart universe is happening. Things are being or becoming possible with the technology that's available today. And I have a small video, if I can. It's only 1 minute. Can we get the video going?
The internet connected us. Wireless and mobile freed us. Now, the next paradigm shift is here. It's called the Internet of Everything, and everyday life will never be the same, changing the way we live, work, do business, and experience the world. And Qualcomm is helping to create its fabric for you.
so this is becoming a reality. A lot of these pieces are available today. Obviously, some of them will take a little bit more time, but we're not going to be that far from that point, actually, with the technology that's available today. Thanks for your time.
Thank you.
No? Here?
Okay, everybody, some quick questions here. We're running a little behind, but I want to leave a couple minutes for you all in the audience. We have a third person that just joined us, Dr. Jan Wren. Jane is formerly with Cisco, but also she's an MD. Began life as an internist. Is that correct? Internal medicine?
Yes, internal medicine.
So I've got a question for her that having to do with IOE and healthcare. Dr. Wren, in what subsectors of healthcare are you seeing initial uptake at scale for IOE?
Sure, that is really a great question. So I'm going to offer some of my perspective, which may be a little bit different from a lot of us who are seeing or going on. So a couple months ago, I made a talk at the IOE Asia in Singapore, where I mentioned that a lot of focus today seems to be on health monitoring. So monitoring a patient's statistics at home and all the places. The reality is the doctors are saying, no, we don't want more data. We want responsiveness, we want decisions. Data means liability. So to doctors, because if it sits in their database, it's going to mean that their actions that did not know to take. So some of the really great, I'd say great application in healthcare wearable actually trigger decisions and trigger the right messages at the right time. If the patient did not pick up the medication from the pharmacies, what are the messages, what are the prompts that changes behavior? If the person's weight changes, what are the things that will automatically send messages to patients? Now this is one aspect. But the most important, the biggest gain in IOE and IoT is actually happening on the hospital floor. I used to work at hospitals and know that $26 billion of US dollars in this industry is spent on medical equipment. And out of those medical equipment, every year they spend, only 43% are used at any time. Most of them are sitting idle because people simply cannot find them. They cannot mobilize them for the right purposes. They cannot set them up for the right procedures. And that is where on the operational center, where the operational intelligence come in, as Pankaj was talking earlier today, that enables the much bigger return bucks or much direct return bucks on the larger scale for IOE.
Terrific. Well, we have the CIO Show Up Healthcare here tonight, so I'm sure he'll be happy to talk to you at dinner time tonight.
That's great. We'll have to.
Okay, Joseph, I had a question for you, but I'm going to change it.
Okay.
All right. So it's probably safe to say the largest consumer of chips in the history of semiconductors has been communications products.
Right.
As a group, right? Communications products. And if I look at the numbers you gave here, is there going to be a problem with fab capacity? Is there going to be a problem producing the silicon that's needed to enable all of this, whether it's Zigbee, whether it's Bluetooth, whether it's Wi-Fi or full modems? We're talking about a market much larger than just smartphones.
Right. It's a good question. I think two things here. Number one, I don't expect that this market is going to go from, let's say, 1 to 10 in one step. So there will be gradual growth in the market. It's going to take some time for the market really to build momentum from a volume perspective. So that will give, I think, the foundries enough time to be able to scale, as the volume grows. The other point is, if I look at a communication chip for a cell phone versus an IoE device, the size of the die is probably 100x larger. So while, with maybe an 8-inch wafer or 12-inch wafer, you can do, let's say, 100 taken just a theoretical number here, 100 die. If you're doing a very tiny die, you're talking about thousands and thousands of chip per wafer. So from a capacity perspective, you'll be able to get much more with smaller dies. And also your yield actually will be even higher in that respect, right? So I don't think it's going to be a problem. With the scaling of adding additional capacity plus the size shrinking, more and more of these devices, I think will be okay.
Even when fabs are costing $3 and $4 billion or more to build.
I mean, so it's either the cost will go up, in which case the cost will transfer to us, but I believe it has to happen. I mean, these foundries, that's what they do for a living, right? So if the capacity is increasing, they're going to be investing more. Now, if the cost is high, they'll transfer that cost probably to us and to the consumer at the end of the day. At least I hope that's the case. Otherwise, we're going to have a problem.
Or you'll be building fabs.
Yeah, I don't think we will build fabs.
Okay. Okay. Pankaj, RFID. What happened to RFID? Why don't we hear about that as much anymore? When you talk about the Internet of Things, connectivity, what happened to that technology?
I think RFID emerged in the market about market hype cycle around 10 years ago. Actually, back then, we had integrated both active and passive RFID tagging systems into the network, and we were instrumenting supply chains and healthcare, asset monitoring with active tagging, dock doors with passive tags. But what happens, I think it was ahead of the curve of the rest of the sensor technology. The IoE world, as Joseph was saying, is going to be all kinds of ecosystems of sensors where RFID is one kind, and it'll have a rightful role. I think it'll be part of the ecosystem, so it'll catch up, it'll play in that architecture. We've already seen with RFID, the data standards were more mature, the technologies were already there to convert it to the IP. We're going to see it more and more in the asset tracking environments. We're going to see it in the large item tracking, but then other sensors will play a role in everything else as well.
So if you look at Bluetooth and Wi-Fi, other RF technologies, is there going to be one that'll dominate, or will it be spread out pretty evenly?
I think because the industries are so varied, the conditions in which all these things will connect are so varied, that there's actually going to be room for all those different plays. It'll just depend on the industry and the usage model. For instance, in the building environments where there are a lot of access points and things, you'll see more RFID. You'll see more Wi-Fi because they'll have the power in the building. On the extreme condition environments like an oil rig or a oil pipeline, others where there is limited power, you'll want the low power Bluetooth, you want the low power capabilities. And so I think what we're going to see, the growth we're expecting, is that all these areas are going to want to be instrumented with the collection of these things. Some will dominate with the kinds of requirements around RFID, some will dominate around Zigbee, Z-Wave, or Wi-Fi or what have you.
Okay, I have one more question, then I'm going to open up to the audience here. And I'd like all of you to kind of answer this. I already asked Joseph this earlier. It was an interesting response. But I know everyone followed the acquisition of Nest by Google for an astonishing amount of money. And I got an interesting view of that from Joseph, but I'd like to have every one of you look at that acquisition and give your opinion to the audience as to why that was such an important acquisition as for instance, Google moves into the IoE area. We'll start with you.
I think Nest is that hub that we talked about in my presentation. It is a sense and respond point where now Google has access to the home. So when my kids leave the home, Nest can be used as the hub to give them the services they need. They will use that to tweet with the devices. Similarly, in every industry we're looking at, the equivalent capabilities coming out. It may not be as consumer-oriented as Nest, but that kind of intelligence at the edge is what we were calling part of the fog architecture as well.
Joseph?
Yeah, I think building on what Pankaj is saying here, It's all, at the end of the day, it's all about the data that Google can get from these Nest devices, right? I think, and I'm speculating here, I mean, Nest is really going after the complete home automation. So really having these devices in the home, getting the data from these devices, using this data to learn about consumer behavior is what I believe Google is after. You know, at the end of the day, their money is coming really from, you know, from their marketing and target marketing and things like that. And I think a company like Nest would help them a lot, you know, in that respect.
Dr. Wren, Nest, regarding healthcare in the home, is there a play there?
I would more comment from the software industry. I think there are two significance here. One is when we think about Google as the dominant player in organizing information for us for decades. Now with this one step, it is stepping into the physical world. So information is not just the data from people searching the web and upload their information. It's things that are acquired from the edge in the physical world when these two worlds start merged. That's the first step. That's of great significance. The second significance is Google sends the signal to the ecosystem and to all the VCs, say, I missed the big thing here, and what are the next companies I need to be looking for, which are like next, and I think a lot of you are building there.
Okay, so we have time for a few questions here. Please speak up. We'll have one way in the back. Let's start way up there. Let's speak up very loud, please, with the microphone.
I'm fine. My question centers around security. As I've studied the Internet of Things, as you call it the Internet of Everything, it sounds like it sounds like, and from what I've seen, the security field is very fragmented. Bluetooth Low Energy has been easily broken with tools that are off the shelf. That's what's being used to power home locks, medical devices, all sorts of pieces of equipment that are out there. And what I've seen in the specifications, including all join and all seen, is that it's up to the implementer to decide what level of security to put into their systems. Given the fragmentation of development, how is it that we can assure consumers of anything, medical devices, home devices, just your lights, that they're not going to be so easily cracked?
Pat Cash, what were you?
No, absolutely. It is one of the biggest issues in this world. While the opportunities are huge, now you have into the internet or the TCP IP environment a lot more points of intrusion, threat, and invasion. And so part of what we're doing on the network side of the gateways, we're putting a lot more distributed network layer security, network layer device identity management. We're also in the cloud that I talked about putting application and software level identity management. And then we're overlaying all that with things like threat defense into these environments, overlay things around intrusion detection. We're going to have to, we can't expect those standards to provide a secure entry point. We have to now secure the network even more with more and more kinds of overlay from layer 1 to layer 7 of the OSI stack.
Joseph, from the wireless network side?
I think, I mean, you know, building on what Pankaj is saying, absolutely, this is a problem, you know, that everybody is scared about today, right? And while I'm not necessarily the expert to talk about this in here, there are some enhancements in the standards, whether it's in Wi-Fi or with Bluetooth LE coming with 5.0, you know, around security that supposedly will address some of these risks and concerns. So that along with what we're enabling in our chips from an encryption perspective, and other security pieces, we're hoping that we can provide that additional level of protection.
From healthcare security?
Actually, an interesting implication on the healthcare side, very, very important patient data security. And this is one actually coming to interacting and doing business with hospitals and healthcares. Sometimes cloud is not always a solution. A lot of the operational and clinical data, if you want intelligence, you have to put it at the edge, which is on their premise, in their secure network, rather than having to aggregate into centrally to be able to process and giving them that result. That in itself solves a lot of headaches. Now, certainly in our software, we build the security system down to the architecture level, to every single step is authorized. But I do want to say on the broad scape, edge is very important.
Next question? Okay, speak up loud.
Yeah, my question's for Dr. Wren. You made an interesting statement about how more data could be more liability in medical. So what are the implications on that? Does that mean
that thank you. The typical high-tech, faster, cheaper, better incrementalism that we all enjoy and that we stand on the shoulders of today, how do we get there if you have to go to some full-blown, gold-plated solution to reduce these liabilities? In other words, can you have pilot programs? Can you have beta programs? How do you get past that obstacle?
So there are a few key things. The key things is how do we convert data into actionable insight that people can do something. That's number one. And two is how do we then convert that insight into an automated process that can help people do something. So a lot of the concern today is data gets aggregated and collected and stored in the doctor's file, but it takes 2 or 3 or 4, 5 more additional people to look through the data to try to take a response and action if the patient blood pressure and weight has changed. And most clinics do not do that. So the key is to use the software to be able to automate and to be generated insight, not just the data.
Okay, anybody over here? Right in the middle. Go, your microphone, please, this lady. Thanks, Alexa.
So we know routers are mainly network layer, running network layer protocols. So, and also Internet of Things about applications and service layer. How Cisco, is going to play the role in the Internet of Things? As are you going to put more stuffs in the up layer, or are you going to extend network layer?
So. We've been doing that for years, and I think one of the things about the network world is every network is a topology of routers and switches, as you said, that handles primarily the connectivity. But what connects all those routers and switches is the ability to do computation. There's compute capacity in that over the years, and more accelerated now, we're embedding application capability. Our partners are embedding application capability, because wherever we can get a packet, we can also form a transaction, an interaction, a service. We can detect and we can enable it. So the packet infrastructure becomes a place where you can embed application infrastructure.
Okay, we're out of time. Sorry about that. But I'd like to, before you leave, where's the slide, Rafa? Where are we going here? Nope.
Keep going.
Nope. The last slide with EcoATM. So somebody put that up. Huh? Stand by. There we go. Okay, if you're not doing anything tomorrow night, and especially if you're a woman in tech, you should be here. EcoATM's president will be speaking. It's Maria Stipp. EcoATM was one of our incubator companies. Graduated, got acquired by Coinstar, Outerwall. They have kept the organization in San Diego, growing jobs here, and Tina will be speaking tomorrow night at Intuit off the 56. Intuit, yay, right up there. So, have you done your taxes yet? So please join us tomorrow night at Intuit. Thank you all for coming tonight. Thank you. Good crowd.